Hi, my name is Julia Silly, and I'm a data scientist and software engineer at our studio. And in this video today, we're going to use data from Tidy Tuesday about food consumption around the world. And we are going to do machine learning using that data and use the patterns of different food consumption in different countries around the world to build a model that can predict whether a country is one kind of country versus another kind of country. Specifically in this video, we're going to focus on hyperparameter tuning. And instead of, this video, instead of showing and focusing on like the whole modeling workflow from beginning to end, is only going to talk about how, when we have a model that has parameters that we can't learn from the data, how do we go about finding what they are? So we're going to focus on hyperparameter tuning for a random forest model.
All right, here we are. Let's get started with some Tidy Tuesday data for this week. So this week's data is about, here, let me paste it in, is about food consumption around the world and and then the CO2 emission that is associated with those different kinds of consumption. And so you can see the columns that we have here are for every country, and then a food category. How much food? How much of that kind of food does that country consume? And then what is the CO2 emission associated with that? So what we're going to use this data for is we're going to look at the country, the food category, and the consumption. We're going to use those three columns. We're going to do a little bit of reshaping, and we're going to use this country information and introduce what continent those countries are from, and we are going to show how to tune hyperparameters for a machine learning model. We're going to do it for a random forest model and show how to use the tidymodels framework to do hyperparameter tuning. So this is this video was hopefully going to turn out a little bit shorter than the last couple that I've done, because we're not going to do a beginning to end modeling workflow. We're just going to show how to do the hyperparameter tuning here. So we are going to explore the data that we have a little bit so that we can understand what's in it, and we're going to put together a data frame that would be good for modeling here. So for the first thing we're going to do, let's load a package called CountryCode here, and we are going to, let me just make this so it's more at the top so you can see it all. So we're going to make a new column that is going to tell us the country or the continent that each of those countries are in. So we're going to make a new column called continent, and we're going to use the function from the CountryCode package called CountryCode. And so the first argument to it is where is the column that tells us what is it coming from. So that in our case is this column called country here. And then let's go down here. So we're going to say origin equals, and if we look at what are our options here, we have a whole bunch of we need to do it. We need to give it an origin. What are we going from? And then a destination. What are we going to? So we can do things like the 3-digit country codes, lots and lots of different options here. So if we actually, let's do this. So if we type code list, it gives us all these different things. Country name in English is what we're going to use, and then there is something in here called continent. Where did it go? Is it up at the top? Yes. So we can do continent. So we're going to say origin equals country dot name, and then destination equals continent, like that. So let's So now we have this new column called continent. Let's just make sure it all worked and that we don't have any NAs. We don't. Okay, so it could find, so the countries, the way they were written in this this column all matched up with what CountryCode, the function, was expecting. All right, so now we're not going to use the CO2 emission column, so let us get rid of that column. Let us now we're going to so this is in a tidy data format, well, very long. And if we're going to use this for modeling, let's actually make this into a wide data format, because we actually want one row per country. And then we want to know how much of pork did Argentina consume? How much of beef did Argentina consume? So we're going to use pivot wider. And we're going to say the names come from the column food category. And then the values come from the column consumption, like this. So we can run that, and so now we have this wide data format, and let's clean the name so we don't have the spaces and the ampersands and the things that are inconvenient to deal with, especially when we go to the modeling functions. So now we have wheat and wheat products. So we've got 11 columns that we can do modeling with, 11 different food products. And then we've got continent, country, and that's what we've got so far. Okay, so here's what we're going to do. Here's the kind of modeling that we're going to use. So we've got how many different continents? Okay, so we've got Africa, the Americas, Asia, Europe, and Oceania, however you pronounce that. Okay, let's say that we are going to predict, we're going to build a model to predict whether a country is in Asia or not, depending on its pattern of food consumption. So we're going to say, hey, depending on how much soybeans and rice and beef and whatnot a country consumes, are we able to predict based on those patterns whether a country is in Asia or in the rest of the world? So we can let's see if we can build a model like that. So to do that, let's go over here and let's make a column that is let's call it Asia. And let's use case when and when, let's say when continent is equal to Asia, it is Asia. And all the rest of the time, let's call it other. And once we have that, let's get rid of the country column and let's get rid of the continent column. And let's turn everything that is a character to a factor. And let's call this food. So food, this is going to be food or food DF or something like that. So this is going to be our data frame for modeling. So Asia over here, that's the one that we're going to predict. And then everything else, the other 11 columns, are the things that we are going to use for prediction. So it happens, in this case, they're all numeric. And that, since they're all numeric, let's make a quick plot using the same package I used in the last, video, called a GGALI, or however we say that. There's a function called ggScatmat, a ggScatter plot matrix. When you only have numeric values, like we do here, we can make a so we give it the data, and then we tell it the columns that have the numeric values like this, 1 through 11. And then in this case, we're going to say divide it by color, give it use the color aesthetic, and in our case, the column that we do that with is this column Asia, and then let's give us some alpha, so some transparency, so that we can see some things. So let's run this. We can use this scatter plot matrix because everything is numeric. Everything is numeric here, which is kind of nice. So let's zoom here so we can see this and take a look of what we've got. Okay, so this is nice for a quick look at our data and understand how things are related to each other, and do a little bit of like exploratory data analysis here. Tidy Tuesday is wonderful because if you go and see what the beautiful graphs that people make, and engage with the community around Tidy Tuesday. So this is, for sure just like a quick glance, but we can see which of these predictors that we're about to use in the model, which of these variables exhibit the biggest differences, and also how we have how we're going to be able to see how like some of these things are related to each other. So for example, here we see, like, let's look at this little plot here is beef and poultry. So notice that in the rest of the world, places that have more beef have more poultry, but Asia doesn't have that relationship. Asia has, some of the places have more poultry, but almost nowhere has any beef. So that is this kind of relationship is something that a decision tree, that like a set of decision trees, is pretty good at learning. Also, we see the biggest difference in just the distribution in rice. Like in Asia, we see lots of people who are eating lots of rice, and less so in the rest of the world. We see interesting differences in the relationship, for example, in eggs and dairy. Some places in Asia eat lots of eggs, but almost nowhere eats any milk, whereas in the rest of the world, it's like eggs and dairy can kind of go together. And so these kinds of interactions are things that tree-based models can be very good at learning. So a random forest model is going to be probably a good thing for us to try, because of the kinds of relationships that we see here between these different kinds of food types, these different patterns of consumption that we see in different kinds of food types. Is there anything else particularly interesting here? We see some differences in soybeans. Yeah. Okay, so that way it is pretty interesting actually now that I'm looking at it, but we'll close it and we will keep going in the interest of continuing to go with what we're going to do here. Okay, so that's it for exploring our model, and now let's talk about tuning hyperparameters. So like I said at the beginning, in this video, we're not going to do a whole beginning to end modeling workflow where we're going to split into test and train, and evaluate the model at the end. We only have 130 rows of data. So what we're going to use this data for that we have is we are going to use this as an opportunity to talk about hyperparameter tuning. So let's get ready for this by making some data that we will use for hyperparameter tuning. So we're going to use the tidymodels framework, and let's set a seed, and we're going to make a set of bootstrap resamples. So let's load this so I can have my precious auto complete here. Okay, so bootstraps. We're going to make a set of bootstrap resamples. So we're going to use that food data frame here, and you can see the default here is 25. Let's make a few more. I don't know. Let's make 30, and let's call this food boot. Okay, so a bootstrap resample is you want to make a data set that is the same size as your original data set, but you draw with replacement. So we have all our data set here has, Argentina and Uruguay and New Zealand and Brazil. And so when we make these sets, these bootstrap resamples, we just draw with resample. So with replacement. So we might get Brazil 3 times. We might get New Zealand twice. Like we just draw with replacement to make a data set that is the same size. It is the same size as our original data set, but it has duplicates in it. It almost certainly will have duplicates in it. So that is the analysis part of the bootstrap. The assessment part of the bootstrap is what is left over, the part that did not make it in here. So we will say, we'll draw with replacement just randomly until we end up at the same size that we had before. And then whatever didn't make it in to our bootstrap sample, that is going to go into the assessment bit, the assessment part of our split. So if we train a model on this split, we'll train it on the 130, and then we will assess it on this 48. And so you can see that the assessment bits on the bootstrap resamples are all different sizes because this side, the bootstrap part, is built with random sampling. It's built with sampling with replacement. So these are bootstrap samples built on our food data set. So they have random sampling combinations of these sets of countries in them. Okay, so we have our sample. So this is the data set we're going to use for tuning, for hyperparameter tuning. And then let's set up our model that we're going to use. So we are going to do a random forest. So the random forest spec, the model specification in Parsnip in the tidymodels framework is rand_forest, and we have to give it a mode, and our mode here is classification. Because remember, we are going to build a model that can tell, that can say whether these countries are in Asia or not, depending on what kind of pattern of food consumption they have. Are they more like, are they a country in Asia or not? Do they have, based on the food that they have. So we have mode equals classification, and then we are, let's look at this here. So the interface to random forest models, let's look at these main arguments for the models. So mtry, trees, and min_n. So these are hyperparameters. So when we train models, there are parameters for the models that we can learn from the data, and then there are some parameters from the models that we can't learn from the data while we're fitting that model. And that's just what hyperparameters means. It's like, it sounds very spacey and sciencey and exciting, but that's all it means, is that it's like parameters for the model that you can't learn while you're training the model. And so this first one is an example of that. How many predictors will we sample when we create the tree models? So a random forest, think of it as a whole bunch of decision trees that are voting. And so as a decision tree has its splits in it, you can imagine making a split that has one predictor, like say rice, like is rice above or below some value, or you could picture that split having all of the predictors, all 11. Should it have all of them? Like that. So that's what mtry is. How many predictors will be randomly sampled at each split when creating the tree models? Trees is a hyperparameter. It turns out it doesn't have a huge effect, so people don't often tune them. You just want to make sure you have enough. And then min n is how many data points are there in a node before you're going to split it further. So if a decision tree, you split, you make a decision, you split, you make a decision, you split. Like how many data points end up in one side of a node before you're going to split that further. So that's another thing you cannot learn from the data itself. You have to say ahead of time whether that's going in. So you can either use best practices, like what do people tell you are the right numbers for these things, or you can tune your model. And that's what we're going to do here today. Okay. So here's how we do this. So we're going to tune two things. We're going to tune mtry. Trees, we're not going to tune. Let's say 1,000 trees. And then min n, we're going to tune like so. And let's call this RF spec, so the specification for a random forest. And let's we also have to set the engine here. Whenever you make a model specification, you need to set the engine. That is part of the tidymodels framework here for models. Is when you make a model specification, you set the engine. Okay, so we made this. Let's look at it. Here we go. We haven't done anything with this yet. We have just set the specification. We're saying we have set it up to what we're going to do. And now it's time for us to actually do this. So there are different ways to do this kind of tuning. You can use different approaches to decide how you are going to search and tune those hyperparameters. The simplest, probably the most straightforward thing to do is just to do it with a grid. Tune grid. This means you're gonna say, hey, I'm gonna try a whole bunch of values for mtry. I'm gonna try a whole bunch of values for min n, and I'm gonna make a grid of those values and try them all the combinations. I'm gonna try all the combinations together and see which one turns out best. So let's tune grid. The first thing we're gonna say here is what is the model? We are gonna say, let's use a formula. So for us, we're gonna predict, if we remind ourselves what's in food, we're going to predict Asia with everything else. We could also put like a recipe here, or something called a model workflow that we'll talk about later, but let's just be the most straightforward and put a formula. Let's put our model here. So the model is the model specification we made, and then let's put our data, are the resamples that we're putting here. And this is, let's save this obviously so that we don't need to right, we need to save it, and then let's get going. Okay, so this is going to take a little bit to run because let's think about what it's doing. It is training a random forest model with every combination of mtry and min n that it's looking at the data here and deciding what would be reasonable values, and then trying every combination together of them here, and it's fitting it. Remember, on our bootstraps, it's fitting that every combination 30 times. So it is fitting it on this data, evaluating it on this data, fitting it on this data, evaluating on this data. So it is fitting every combination of mtry and min n on every bootstrap and evaluating it on this. And so that is why this takes a while. So this is a tiny data set that is toy data set, in fact, you might say. So in a realistic circumstance, this might be when you get up and go to get your lunch or something, because of how this just in real life, like how this would take a while to work. This I may actually edit this video depending on how long this actually takes to run. I think it will run here in a it will finish here in a moment. While it's finishing up, let's talk about what we're going to do here once we have our grid done. So our grid, once it's done, we are going to do a couple of things. The first thing that there it finished. Okay, the first thing that we're going to do is we're going to do collect metrics. This is going to let us see what kind of metrics did we get. So let's see what we have here. So these are the splits that we use for training, and then here are the metrics here, and then any notes of what happened. We don't have anything there. So if we collect metrics, what do we get? So we get here, let me do that. Okay, so the collect metric, so here are all the values for mtry that we tried. So remember that mtry is the number of predictors that will sample, and mmin is the number of data points that you have to keep going. So here's mtry. Remember 11, that's the total that we had in the data set altogether, and then 2 is we started from 2 to the total that we had, and then we had only 130 data points altogether in this data set, so we went from 4 to 37 or so here. So these are all the different m, min, m values that we tried. So we tried all these different values in different combinations together. And here are, for each of the, along this grid, in this grid that we searched out, we measured the accuracy, and we measured the area under the curve. You can, if you're interested in different metrics for your particular problem space, you can set those, and you can measure different metrics there. And we have for the set of 30 bootstraps that we have the mean for these different metrics. So that's collect metrics, and then we can also say, hey, tell me the best ones, and we can say by what metric do we want the best ones. So let's say we want the best ones by AUC, and these would be, it'll say, hey, here are the 5 best ones, and we can say, okay, here were the best ones for here are the best model hyperparameters that we get for going from here at the bottom are the very or I'm sorry, it goes from top to bottom, right? Here are the very highest, and here are the 5 best examples that we have of models that we trained. So this is an example of how to do model hyperparameter tuning using this framework. So this isn't a beginning to end model workflow, but instead it shows how, when you have some data that you want to understand what is the best for this particular data set, what are the characteristics of the specific model that I would want to use to train on that model.
All right, we did it. One note, you can use parallel processing to do this tuning, this hyperparameter tuning. You saw me sit there and wait for a little while, and it slipped my mind until I right after I finished the screencast that you can use parallel processing with these tuning functions in tidymodels. The bootstrap resamples and the grid is all, like all the parts of the grid are all independent of each other, and so it is of course a perfect opportunity to use parallel processing. All you have to do is register a parallel backend, and then it will use that backend for you, and you will not have to wait as long, which is, of course, good news. Also, if you want to specify the grid that you are going to use for the grid search for the hyperparameters, you can do that using the dials package. So that is it for today, and I will see you next time.